Okay, so today when we are solving inequalities, it's going to require to undo the inequality to get it solved. We're going to have to do multiplication and division. So it says right here at the start, when using inverse operations of multiplication and division to solve inequalities, if you multiply or divide by, by, and it's circled because that's the important word. If you multiply or divide by a negative number, if you multiply or divide by a negative number, what did we do to the inequality symbol? We had to reverse it to make it true. Reverse the inequality symbol. So again, let's go, oh, I think I've erased it. I think when we were multiplying over here with a positive number, do you remember when we were multiplying by a positive? Did the relationship change? Did it turn out to be false?
No.
No, we were multiplying by a positive. We were dividing by a positive. Then we didn't have to worry about it. 2/3 is less than 1 2/3. And we ended up with 6 is less than 15. That turned out all right. But once we started multiplying or dividing by a negative, then we ended up with false statements. So this right here, this is a really important thing. It has to be multiplied or divided by a negative number for us to reverse it. Okay, so let's start practicing what we would do. Our first one, we have negative 3x is less than 27. How are we going to get x alone?
Add 3.
No, x is being
Multiplied.
multiplied by negative 3, so we need to divide by negative 3. So we're going to take negative 3x. It's going to get divided by negative 3. And 27 is going to get divided by negative 3. Right now, this is just our step of work. We're showing that we're going to divide both sides by negative 3. By negative 3. So when we divide by a negative number, our negative 3's will cancel out and we'll have x by itself. But we divided by a negative, so we have to switch our symbol. And what's 27 divided by negative 3?
Negative 9.
Negative 9. So our variable is by itself, and we have our solution. So we're ready to graph it. Negative 9. What's the integer neighbor to the left of negative 9? Negative 10. What's the integer neighbor to the right of negative 9? Negative 8. Okay, what kind of a circle are we going to put at negative 9? Should we shade it in or leave it open? Leave it open. In other words, negative 9 is not included. Which numbers on the number line are greater than negative 9? Is it negative 8 or negative 10? Negative 8. So we're going to shade in the direction of negative 8. Okay, I just want us just to stop for a moment to pause and think about what if we had not reversed the symbol. Okay, so whenever we do shade like this, we should be able to take any number from that shaded region, put it back into the inequality, and it better make it true. So we could put negative 8 in. If we put negative 8 into this inequality for x, we would take negative 8 times negative 3. What is negative 8 times negative 3? Positive 24. So we would end up with positive 24 is less than positive 27. How do you feel about that? Is that true?
Yes.
Is 24 less than 27?
Yes.
So I'm feeling pretty good about our solution and our shading. What if we just said, it doesn't matter, we don't have to switch that symbol, and we didn't switch it, and it got left like this. And we left it like it was. Which way would we shade then?
Towards the 10.
Then we would have shaded this way, wouldn't we have? And then we would have said negative 10 is the solution. So let's try negative 10 in there instead. What's negative 3 times negative 10?
30.
Positive 30. Is 30 less than 27?
Nope.
No, it's not. It would have made it false. So if we don't remember to switch the symbol, then we're going to end up with the wrong region being shaded, and we'll have the wrong solution. Okay, anybody got questions so far? Okay, let's look at number 2. What do you think we're going to do? Okay, we're going to divide by 1.5. Okay, negative 6 is going to get divided by 1.5. And 1.5x is going to get divided by 1.5. There's plenty of lines there to show your work, you guys. You don't have to put the fraction bar right underneath the beginning problem. Write it again. What's a negative divided by a positive, first of all?
Negative.
A negative. So we're going to get a negative here. Anybody happen to know how many times there's $1.50 and $6? 4 times. So this is going to be a negative 4, isn't it? Okay. Trey?
Do we have to switch it around?
Okay, do we have to switch it around? He wants to switch the symbol. Do you guys want to switch it?
No. Because you want to.
Why not?
But you want to be X's around.
Well, wait a minute. Don't worry about the X being on the wrong side right now. We're solving first. Don't be switching it up on me yet. We gotta decide if we should switch it because we divided. Should we switch the direction of the symbol right now because we divided by 1.5?
Yes.
Did we divide by a negative number?
No.
We divided by a
Positive.
positive number. We don't switch the symbol. We don't switch it unless we divide by a negative. Don't worry about what you're dividing into. That doesn't matter. What were you dividing by? We were dividing by a positive, so we don't have to switch the symbol. Now, Trey, we have our solution, but we don't really like when our variable's on the right side instead of the left side, so now we'll switch it so that the x is on the left side. So now we'll make it x is less than. We'll have everything's going to flip over. So we didn't flip it over because we divided by a negative. We flipped it over so that x could be on the left side. We want x over on the side that makes it easier to get a graph. Integer neighbor to the left. Negative 5. Integer neighbor to the right. Negative 3. What kind of a circle should we have at negative 4? A filled in one. What way should we shade? To the left, towards we need numbers smaller than negative 4, this says. That would be negative 5 and all those other guys headed that way. Okay. Questions? Okay. Let's look at number. You need to have really good notes here, step by step. Don't leave anything out, because tomorrow when you're working on this, you're gonna be like a little rusty. You're gonna be like, oh wait, we did that yesterday. I don't know if I remember. With getting a night out of homework, you're gonna look at this tomorrow and it might look kind of foreign. Okay, let's look at number 3. Negative 1/3 is less than x over 6. What does x over 6 mean? What
X
operation?
divided by 6.
X divided by 6. So if x is being divided by 6, how do we undo dividing?
Multiplication.
Multiplying. So what are we going to do? Multiply both sides times 6. So this side has to be multiplied by 6, and the other side has to be multiplied by 6. So this is what we're multiplying by right here. That's what's happening on this. We're doing the same thing to both sides. Well, over here, what happens with the 6s on the right side? They cancel each other out. One's up and one's down, and we're multiplying. Cameron?
Is it okay if you put the x over 6 by the symbol and then put this multiply 6 on the outside?
Yeah, absolutely. Okay, could we put this 6 over 1 so it's a fraction also? Okay, because now we're going to take a positive times a negative. What's a positive times a negative?
Negative.
A negative. 6 times 1 upstairs is?
Negative 6.
6. And downstairs, 1 times 3 is? 3. And did we multiply by a positive or a negative number?
Positive.
We multiplied by a positive number, so do we have to switch the symbol? No, we do not have to switch the symbol. Okay, can negative 6 be divided by 3 nicely? What does it become? Negative 2. So negative 2 is less than x. And because the variable's on the right side, we say, okay, now I'm going to write it so that the variable and the negative 2 trade places. And when they trade places, the symbol has to switch over also. It has to go the opposite direction. So there's a couple of different reasons we make the symbol change. One of them is so the variable can be on the left. The other is we multiply or divide by a negative. So we have two different reasons, and you got to keep them straight. Which one is the reason you're doing it? Open or close circle at negative 2?
Open.
Open, shaded. To the what?
Right.
To the right. We need numbers bigger than negative 2. So we need negative 1, 0, 1, all those guys. They're bigger than negative 2. Okay, so any part of that you didn't understand. Okay, then let's look at what our fourth one is here. Negative x is less than negative 14. What's that negative sign in front of x mean?
Negative 1.
There's really, x is really being multiplied by a negative 1. So let's rewrite on the next line, let's rewrite it putting that negative 1 in there. So negative x means x really is being multiplied by negative 1. So then what does that mean we have to do to get x alone? We have to divide by negative 1. So we're going to have negative 1x divided by negative 1. Negative 14 divided by negative 1. Okay, on this side the negative 1's cancel out, and we have x. Should we reverse the symbol?
Yes.
Why should we reverse the symbol? We divided by a negative, so we're going to make it is greater than. And what's negative 14 divided by negative 1?
14.
Positive 14. Okay. We're ready to graph it. Remember, without having to use a ruler and measure it, you should be showing, equal distance between your integers. Should we shade that circle in 14?
No.
Okay. And should we shade to the left or should we shade to the right?
Right.
Let's shade to the right, okay. Okay, we've just got a couple more to do on the map, and then we will be done. And this is what we'll just do, take a quick look at again tomorrow morning at the beginning of class before you do some practice problems with it. Okay, let's go to the back side. Sometimes there's fractions all over the place, but we don't let those scare us. We say on the side where x is, what's happening?
Being multiplied by 2 thirds.
Wait a minute, what's happening on the side with x? X is being multiplied by 2/3. Okay. Well, if x is being multiplied by 2/3, that means we need to
Multiply by a reciprocal.
Yeah, we need to multiply by the reciprocal. Remember, whenever there's fractions involved with dividing, typically they don't divide out that nicely. So we just change it to multiply by the reciprocal. So we're going to take both sides times the reciprocal of 2/3. What is the reciprocal of 2/3?
3 over 2.
3 halves, yeah, 3 over 2. So we're going to take both sides times 3 halves. So both sides, the same thing is happening. We're not changing anything else up about the equation. So we're multiplying both sides by 3 halves. On the left side, the 3's and the 2's cancel. And we have x by itself. Before we worry about the right side, we stop and say we're at the inequality symbol. Do we need to switch it?
Nope.
Why not?
We didn't multiply by a negative.
We didn't multiply by a negative, we multiplied by a positive 3/2, so we don't have to switch the symbol. And then now let's do, we have a positive 3/2 times a negative 3/4. What's a positive times a negative?
Negative.
Negative, so it's going to be a negative answer. 3 times 3? 9. 2 times 4?
8.
8. Because we are going to have to graph this, we're going to want to change it to a mixed number. So what is the mixed number name for negative 9/8?
1 and 1/8.
Yeah, so x is greater than or equal to a negative 1 and 1/8. There's our solution. And now we will graph it using our number line sense. Negative 1 and 1/8 is between negative 1 and
2.
negative 2. So we need negative 2 over here, right? Actually, you know what we're going to do? Would you start your number line over with me? Because it's between two integers, we're just going to put those two integers on. We don't have to worry about a third integer. It's between negative 1 and negative 2. We just got to decide approximately where between them. Should we go halfway between?
No. Yeah. Closer.
Should we go a quarter of a way between?
No.
No.
A little
She
bit
gets
of 1/8.
basically
Go an eighth of a way over, right? So we could say to ourselves, halfway would be about here, and a quarter of the way would be about right there, right?
1/8
So we wanna
is
go-
right on it.
We want to go right here and say this is negative 1 and 1/8. We're going to the left, an eighth of the way. So with my little blue marks, I was kind of trying to figure out half and quarter. So this is negative 1 and 1/8. It doesn't look very good. I'll try and clean it up here. Okay. Open or close circle?
Close.
Closed. Which direction should we shade? To the right. The number's greater than negative 1 and 1/8, head to the right. Okay. So we want to make sure we just don't slap it somewhere between negative 2 and negative 1. We want to find out where would it actually on the number line be. So anyone got questions about number 5? Any part we need cleared up? Okay, then we got one more to do. That's law. We got to set up our own inequality statement first of all. So 7 is no less than the quotient of x and 3. I like that they use the word is here because that tells me there's I'm going to have some sort of a symbol going on, not an operation symbol, but an inequality symbol. So is no less than. We got to figure out how that would look. Josh, what do you think? Pardon? Okay, so we could start with our 7, and you're saying it should be is greater than or equal to? Is that what you're saying, Josh? Okay. The quotient of x and 3.
X plus 3.
Quotient
X.
means addition.
X over 3.
X divided by 3, x over 3. So let's kind of, maybe that we could go at this a little bit backwards. The quotient of x and 3, that's what we have over here. We have 7 out on the other side, and it says is no less than. They use the word less than. How come our symbol is greater than, Josh?
Because it's
If 7 is no less than, what does it have to be?
It can't be.
It's going to be more than, right? If it says it is no less than, then it has to be more than. So is greater than, 7 is greater than, is more than. So it's kind of like saying, when you said, this says that is no less than, it's kind of like saying, well then we want the opposite of that. So if it can't be less than that, then it's got to be greater than that. So this is the correct setup. Okay, now let's solve it. What are we going to do to solve this?
3 times itself.
X is being multiplied or divided by 3, so we need to multiply both sides by 3. Both sides get multiplied by 3 because we want to undo that dividing by 3. What's 3 times 7? 21. Do we need to switch the inequality symbol? You gotta get in the habit of asking yourself this every time when we're multiplying and dividing. Do you need to switch the inequality symbol? No, we multiplied by a positive, and on this side, those 3's cancel out, and we just have our x, okay? But the x is on the
Right.
right. So since the x is on the right, and we like it on the left, we're gonna say, now, let's flip this baby over. X comes over here, 21 goes over there, and the symbol flips over also. Okay, and now we can graph it. What should we do with 21? Should we include it or not?
Yes.
Okay, include it by shading in the circle. And what other numbers go with it?
20 and lower.
20 and lower. Okay. We did it. We made it through the notes. Okay, where do they go now? In a safe place in your binder. We're going to use them tomorrow when you do your homework on this lesson.